Hi, my name is Evan, and I'm going to teach you guys how to do an optimization problem. Okay, so my mom, she works for architects, and a lot of times they try to figure out how they can use the maximum area of a certain product that they have. And one of my mom's clients, they said that they had fencing that was 3,000 feet long, and they needed to be able to separate this fencing so that they had a maximum area. But they had 3 different locations that needed to be optimized. So they had a big property like this, but they divided it in the middle, and once again, so that they could have a garden area and a pool area, and these are all equal. And so they're trying to figure out, how can I use all of this space with all of this fencing and have the maximum area? And so what they did first was they marked everything. So they had an X, this is Y, since these are 2, this is another Y here, this is 2X, we have X down here, X here, Y, and Y. And in all, they had 1, 2, 3, 4, 5, 6. They had 6 X's. With 1, 2, 3, 4, supposed to go, and 5 Y's, which equals the 3,000 yards of fencing they have. And so optimization, this would count to be your secondary equation. What they were trying to find was the maximum area. So that would still serve as your primary equation. And so the area will be 2x times 2y, which we can convert to be 4xy. Now what we do is we try to plug one of these variables in here, and then take the derivative of it. That's kind of the whole point of optimization. So the next thing we would do is we would subtract 6x from both sides. And what you end up with is 5y equals negative 6x plus 3,000, sorry. And then you divide 5 by both sides, and you get y equals negative 6, 5x plus 6,000. And then what you do is you plug this y into here. So your area would equal 4x times basically all of this. So negative 6 over 5x. So now what you can do is you can distribute this 4x to these 2 terms, and where you would get a equals negative 24x over 5, x squared over 5, plus 24,000x. Now the next step to solving this, to actually find the maximum, is to take the derivative. So when you take the derivative, this a turns into a 0 because it's a constant, and then you bring the 2 down, so it's negative 48x over 5 plus, just bringing this x down, so this is technically x to the first power, and by differentiating it, it's just 2400. And so now what you can do is you solve for x. So you have 48 fifths x equals 24. So now what I would do is I would have x equals 3,000 times 5 over 48. And what you would get is, so if you divide 48 by 4,000, you get, okay, I'll pause it. Please stop it.